Maupay nga adlaw sa iyong tanan. Welcome to my channel. Our topic for today is logarithmic function formula of integration, LF. So, logarithmic function formula of integration will suffice the limitation of the power formula, which cannot be applied if the function u raised to n has a power of -1. So before we derive the formula of our logarithmic function, let's recall first our power formula. Our power formula is equal to u raised to n du is equal to u n plus 1 over n plus 1 plus c. So this is only true when your n is not equal to -1. What if our value of n is equal to -1? So the power formula is not applicable anymore. So let's derive our formula of logarithmic function of formula of integration. So let's start with differentiating the function y of your lone u. So we'll let u greater than 0. So if we recall, if we are going to differentiate your lone of u, your answer is 1 over u. Or if we let u less than 0, and by chain rule, we can say that the derivative of your u, lone u, is equal to derivative of your u, lone negative u. Then your 1 over u, then the derivative of your negative u. Finally, your 1 over u. Okay, so by the definition of integral, if we're going to apply its inverse, our formula for logarithmic function will be equal to the integral of your u raised to 1 du equal to lone absolute value of u plus c, or in other form, integral of u is equal to lone absolute value of u plus c. So this is our third formula. So we have our second formula, our power formula. Okay, before we proceed to the example number 12 problem, let's recall and summarize the formula we have taken. So as a summary of a formula, we recall that integral of a function du is equal to u plus c. So this is our first formula by the definition of integral. Okay, for our second formula, our u n du is equal to u n plus 1 over n plus 1 plus c, or in other form, this is true when our n is not equal to -1, or In other form, n integral of the derivative of your u is to n is equal to negative 1 over n minus 1 u n minus 1 plus c. This is true naman if your n is not equal to 1. So this is our second formula, or we called it our power formula. So for our third formula, d over u is equal to ln absolute value of u plus c. So this is our third formula, LF, or logarithmic function of integration. Okay, I think we're ready to proceed to our sample problem. So for our first problem, go to your workbook, page 25. So evaluate example number 12. We need to evaluate the function x squared dx over x cubed minus 2. So our first step for our solution, so as we recall, we have three properties of integration. One property is like a distributive property. Second property, you need to carry out your constant to the other side of the integrand symbol. And for number 3, we need to determine the correction factor of your function you're solving. So we were going to apply our property number 3. Property number 3. So we determine the CF, or the correction factor. This case, we let u equal to x cubed minus 2. So first derivative of your x cubed minus 2 is 3x squared. So now your dx is equal to the reciprocal of first derivative of your constant, du. So finally, your dx is equal to 1 over 3x squared du. So in our solution, we can now apply the correction factor. So if we have x squared dx over x cubed minus 2, so if you're going to apply our correction factor, so our x squared, our dx is equal to 1 over 3x squared du all over. So we need to replace our x cubed minus 2 with our u, since we let u equal to x cubed minus 2. So u. We can apply some elimination. So x squared. So x squared. So the remaining is 1/3 of du over u. Okay. So property number 2, we can let the constant carry out over the integrand. Okay, here by this form we can apply now our third formula, the LF, logarithmic function. So we need to apply our LF. Again, what is the formula for our LF? LF or the integral of du u is equal to ln absolute u plus c. Applying our formula LF, so 1/3, so ln u, pareho na the same format as the formula. So ln absolute of u plus c. So we need to recall the value of your u, which is equal to x cubed minus 2. So finally, your final answer is 1/3 ln absolute value of your x cubed minus 2 plus your constant. So this is your final answer. Okay, let's move to another example. So evaluate in example number 13, you need to evaluate the integral of x cubed plus 4x all over x squared minus 1 dx. Okay, so since the degree of the numerator is greater than the degree of denominator, therefore we can simplify and evaluate this polynomial. So by simply dividing your polynomial, so your x cubed plus 4x all over x squared minus 1 dx is also equal to integral of quantity x plus 5x over x squared minus 1 dx. So applying our property number 1 here, apply property number 1. So we need to distribute our integral sign on our dx. So as a result, we have x dx plus integral of 5x dx over x squared minus 1. Okay, so we can apply power formula at our first term. Okay, we simplify further. So if we apply power formula here sa first term, apply power formula number formula 2. And sa second term, first we need to apply property number 3, or we need to determine the correction factor of our function. So we let u equal to x squared minus 1. So first derivative over u is 2x. So your dx is equal to the reciprocal of your first derivative du. So finally, your dx is equal to 1 over 2x du. Okay, so we apply our correction factor Then, after applying our correction factor, we can apply the third formula of integration, our LF, logarithmic function of integration. So apply correction factor, then LF, our formula number 3. So x 1 plus 1 plus 1 plus here. So if you're going to apply our correction factor, so 5x, so our dx will be 1 minus 2x du. Then replace our x squared minus 1 by our u. So let's cancel our x and then carry out our constant 5/2 integral of your du and u. So dito naman we have x squared over 2. Then we can apply our third formula. So x squared 2 plus we have 5/2 applying our logarithmic formula. Du is ln absolute value of u plus c. So then recall our u, x squared minus 1. So finally, our final answer is x squared over 2, 5/2 ln absolute value of x squared minus 1 plus c. Okay, so this is our final answer. So let's check if we have the same answer with our workbook. So they have the same value. Okay, so let's proceed to our next example. Example number 14 can be found in your workbook, page 28. So evaluate the integral of dx over ln x. Dx over x ln x. Okay, so our first step for solution is we need to apply our property number 3. Property number 3. So we need to determine the correction factor of our function. So we let u equal to ln x. So first derivative for your ln x is 1 over x. So your dx is equal to the reciprocal of your first derivative of your constant du. Finally, your dx is equal to 1 over x. So your dx is equal to x du. So if we have your integral of dx over x ln x, so if we're going to apply the correction factor, your dx is equal to x du over x ln. So our ln, so we need to replace this with our u. Our ln x will be our u. Okay, so we can apply some isolation. So finally, our du over u is in place. So recalling our formula, can apply the ln of absolute of u plus c. We just need to recall our value of our u, which is ln x. So finally, our final answer is ln absolute value of ln x plus c. So this is our final answer. Okay, so let's proceed to our next example. Example number 15 that can be found in your workbook on page 29. So let's evaluate the integral of 5x. Evaluate 5 dx over 3x plus 2. Okay, so before we apply our property number 3, or determining the correction factor, we can simplify first our function. 5 dx 3x plus 2 also equal to, so dx over 3x plus 2. So it's in place, so we can determine our value of correction factor by letting u equal to 3x plus 2. So first derivative of your u is 3. So your dx is equal to the reciprocal of the first derivative of your constant du. 1 over 3 du. Here we can apply our correction factor. Apply correction factor. So 5. So our dx is 1/3 of du over u. So we can move our, okay, so would be 5 1/3 du over u. Now we can apply our third formula, the logarithmic function number 3. Okay, so this is 5/3. So ln of absolute value of u plus c. So we can recall our value of u, which is 3x plus 2. So for your final answer, 5/3 ln absolute value of your 3x plus 2 plus c. So this is your final answer for your number 15. So let's proceed to your problem number 16. So number 16 can be found in your workbook on page 29. So we need to evaluate the integral of 3x minus 2 all over quantity 1 minus 3x squared dx. Okay, so our first step is we need to simplify our function first. Okay, solution. Integral of 3x minus 2, 1 minus 3x squared dx is also equal to integral of quantity 1 over 1 minus 3x minus 1 over quantity 1 minus 3x squared dx. So we need to apply our property number 1. So we need to distribute your integral and your dx. One over 1 minus 3x dx minus integral of 1 quantity 1 minus 3x squared dx. Okay, so we will apply our correction factor or determine the correction factor in both terms, or term 1 and term 2. So if we're going to determine the property number 3, determine our correction factor, we let Ru equal to 1 minus 3x. So as you notice, if we're going to determine our correction factor in both terms, pareho lang, except the other term is squared and the other term is not. So first derivative of your u is negative 3. So your dx is equal to the reciprocal of your first derivative of your constant du equal to 1 negative 1/3 du. So that is our correction factor. Okay, so if we apply our correction factor in both terms, in both function, so apply CF. Okay, so we let our negative side outside, so 1 or we can write it dx over 1 minus 3x minus dx over quantity 1 minus 3x squared. So if we apply CF, our correction factor in both sides, so negative, so our dx is negative 1/3 du, 1 minus 3x and negative 1/3 du, 1 minus 3x squared. Okay, let's continue. So we're going to rationalize, move our constant away outside. So negative times negative, that would be positive 1/3 integral of du. So replacing it by u here. Okay, correction factor negative 1/3 of your u, replace it with your u squared. So first thing, we can apply here our formula number 3, our LF. And the other side naman, we can apply our power formula, PF. Okay, so 1/3 ln over U minus 1/3, applying our power formula, one. Applying for formula A and B, we use our formula B. As you can recall in our previous summary of formula, that would be 2 minus 1 U, 2 minus 1. Continuing, there is negative 1/3 1 over U plus C. So finally, we can rewrite our final answer and we recall the value of our U. So 1/3 ln absolute value of our U is 1 minus 3x minus 1/3 1 over 1 minus 3x plus C. Or simply, we can rewrite our final answer here at the top. 1/3 ln of absolute value 1 minus 3x minus 1/3 over 1 minus 3x plus C. So that is your final answer. So let's proceed to our next example. Example number 17. Example 17, you can find it in your workbook on page 30. So problem 17, we need to evaluate the integral of sec squared e raised to negative y dy all over e raised to y tangent ay. So for our solution, first we apply our property number 3, determining the correction factor. So we let our u equal to tangent e raised to y. So if you're going to differentiate or get the first derivative of tangent e raised to y, that is equal to your negative secant 1 over e raised to y squared all over e raised to y. Or we can rewrite this into secant e raised to y negative squared all over e y. Or we can still rewrite this to simplify. Secant squared quantity e is to y all over e y. So for your dy, that's the reciprocal of your u du. So that is 1 all over negative secant squared a negative y all over a y. So double denominator, we can put this up. So may pa yan du. So finally, your dy is equal to e raised to y negative secant squared a to y du. So by applying our correction factor, secant squared e y dy a y tangent e raised to negative y. So we apply our correction factor. Integral of secant squared a raised to negative y e y negative so secant squared a raised to y du all over e y. So we need to replace our u, our tangent e raised to y, as our u. So we made some cancellation. So common cancel. So we have negative. So common gihap. Finally, remaining is your du over u. So you can apply your third formula, LF. So the ln of absolute value of u plus c. Okay, so we still have negative here. So don't forget to write your negative. So then we recall our value of our u. So final answer is negative ln absolute value of u, which is tangent e is to y plus c. So this is your final answer. Okay, so please be reminded that Ru is negative. So still, if we get the derivative of your u, still we get this one. We just rewrite our function. So that is your final answer for your example number 17. So let's proceed to our last example. Example number 18, page number 30 in your workbook. So example number 18, we need to evaluate the integral of cotangent hyperbolic 3x dx. For solution, integral of cotangent hyperbolic 3x dx. So we apply property number 3. So we determine the correction factor. We let u equal to 3x. So first derivative of your u is 3. So your dx is equal to the reciprocal of first derivative of your constant du. So your dx is equal to 1 over 3 du. And we can apply our correction factor. If we're going to apply our correction factor, cotangent hyperbolic 3x, your dx is 1/3 of your du. And replace your 3x as your u. So we move our 1/3 to the other side of the integrand. So cotangent hyperbolic of u du. So we recall our formula for our cotangent hyperbolic u is equal du is equal to ln sine hyperbolic of your u plus c. Okay, so 1/3 ln sine hyperbolic u plus c. Then we recall our value of our u, which is 3x. So our final answer is 1/3 ln sine hyperbolic of 3x plus c. So this is your final answer. So for your exercise number 2, you can submit your solution and your final answer in your Moodle account. So that's all for today. Thank you everyone and have a nice day.